Rules for the nth term in a sequence modeling geometric growth or decay. So this is when I need to find if I'm doing either a compound interest or a reducing balance depreciation. If I want to know what is the value after 12 years, what's it going to be without having to go through all of these sequences. So in other words, this is when we have to develop a rule rather than using the recurrence relation. So we use this same principle that the V naught is the initial value, and the rules are the same sort of idea. So Vn plus 1 is equal to A Vn. That's the recurrence relation. As you know, when A is greater than 1, that's a growth. When A is less than 1, then it's decay. Then the amount after n periods of growth is given by, and this is the rule. So Vn is equal to whatever that A value is to the power of n, so that's after n periods, so it could be months, it could be years, times by the initial amount. So the rule to establish this or to find out these is to use Vn is equal to R to the power of n times by V naught. So what do all of those mean? So V naught is the principal. The R, the capital R, is equal to 1 plus little r over 100. So that's the compound interest sort of rate or installment each time. The little r is the interest rate as a percentage, and then n is the time periods. The total amount with reducing balance depreciation after n time periods. Well, the rule looks awfully similar to the last. Vn is equal to capital R to the power of little n times by V naught. So what do all those symbols mean? Again, very, very similar to the previous with the compound interest. So V naught is the principal or the initial value. Capital R, in this case, since it's reducing, it's 1 minus little r over 100. So, but when you see depreciation, don't get it confused with unit cost depreciation or flat rate depreciation. This is reducing balance depreciation. So that's 1 minus little r over 100. The interest rate, the little r, is the interest rate per compounding period, and n is the number of time periods. Example 8F.1. A principal value of $90,000 is invested into an account earning compound interest at a rate of 12% per annum. The recurrence relation for the value of the investment is equal to V naught is equal to 90,000. Vn plus 1 is equal to 1.012 times Vn. And because that number is greater than 1, this is a geometric growth. So that indicates to me that I should be getting bigger numbers. Write the rule for the value of the investment after n years. So Vn is equal to, so I'm going to take this 1.012 is the capital R. So that's going to be 1.012. We're doing it to the power of n because that will tell us the time periods, times V naught, which in this case is 90,000. Find the value of the investment after 4 years, rounded to the nearest cent. So that's, as soon as you see nearest cent, that is 2 decimal places. Some people like to make this lives more difficult and try to say, oh, I should round up to the nearest 5 cents. No, it's not what the question was asking, to the nearest cent. So don't do anything other than to 2 decimal places whenever you do these. Always keep the unrounded figure until the very end. Generally, that would be the other thing that I would suggest. So find the value of the investment after 4 years. So 1.012 to the power of 4 times by 90,000 is equal to, so we can do it like this, 1.012 to the power of 4 times by 90,000 gets me 94,398 and says 0.38. So it's going to be 94,398 and 38 cents. Find the amount of interest earned after 4 years rounded to the nearest cent. Now you might be thinking, is that the exact same question as part B? No. The part B is telling me my total value after 4 years. Part C is asking for just the interest. So what was the extra fee being added onto it? Well, to find the interest, so interest is the total amount minus the principal. Because it's what I've got now, take away what I initially had. So this will be 94,398.38. Take away 90,000. And this will get us our initial number. And get 4,398 and 38 cents. So $4,398 and 38 cents. Now, part D, you might be thinking that you're stuck in a Groundhog Days type situation. Like, I feel like I've answered this question like 3 times already. Find the amount of interest earned in the 4th year, rounded to the nearest cent. So what that means is that I don't want the part C was asking how much interest I had after 4 years. So that was the interest that I've accrued over that time. D is asking for, all right, how much increased from the 3rd year to the 4th year. So what we're going to do is we're going to find out what the total amount for the 3rd year, or the interest in that that had happened in the 3rd year. So the total after 3 years, and then what we're going to do is we're going to subtract that from the total after 4 years. So just to explain what we're doing, so we're going to do the total interest after 4 years. So that's my answer to C. Take away total interest after 3 years. And this will tell me how much interest there was in the in that year. So we've already got the answer to the first part. So this is equal to 4,398.38 minus. Now what we're going to do here is just to be efficient. So to find out how much interest there was, we need to work out what the amount that we had after 3 years. So it'll be 1.012 to the power of 3 times by 90,000. And then we'll take away 90,000 from that. So we can do that all in the calculator. This time I'm actually going to use the CAS, I think. So there was 4 years. We have 1.012 to the power of 4 times 90,000. Take away 9,000. That gave me the amount of interest after 4 years. Well, I can just highlight and copy that and just do 3 years. And I got 3,279.03552. So what I'm going to do is I'm going to take that first number, subtract it from that second number, and I get the amount of interest that occurred in that year. So that is $1,119, and in this case it'll be 35 cents. So this is equal to 1119.35. Now, as a point of contention here, you might be wondering, well, actually using the unrounded, if you use the rounded figures here, you'll probably find that you'll end up getting 0.34 as that. Again, we'd always recommend using the unrounded figures. Use the original values where you can. The only time you should use the rounded figures is if the question specifically states. That would be enough arithmetic, by the way, just to get your consequential marking if you need to. So it's always worthwhile putting these little statements in. If the interest compounds monthly instead of yearly, write down a rule for the value of the investment after n months. Use this rule to find the value of the investment after 4 years or 48 months. So this time what we'll need to do is we'll need to go and adjust the formula accordingly. So the first thing we need to do is to change the interest rate, because that is currently in years. But when we're compounding in months, we need to turn that into months. So it's 12% per year. And we need to divide it by 12 months. So that means it's 1% per month. So my new R value is going to be equal to 1 plus little r, which is 1 over 100. And that is going to be equal to 1.01. And then I just need to establish my new rule. So V naught is equal to, I think it's the same amount, so 90,000. And this case, this would be Vn plus 1 is equal to 1.01. Actually, we want a rule, not a recurrence relation. Yeah, better go and get my things right. So Vn is equal to 1.01 to the power of n times by 90,000. So when it says find the rule, that's what you need to write. You actually don't need to write the V naught. That's only if you've been asked for a recurrence relation. If you need to write a rule, just write that. That will be fine. So one of the marks would have been for getting the rule for this. So now we need to find out after 4 years. So Vn is equal to 1.01. Now it's after 4 years or 48 months. So to the power of 48 times by 90,000. Now this one will be, sometimes when it gets big powers, the calculator likes to have a hissy fit. Hopefully it won't. 0.1 to the power of 48 times by 90,000. And there we go. So the total value here. Now now do we need the interest or do we need the total amount? It says there, use this rule to find the value of the investment. So this is the total amount that it wants. So this is going to be $145,100.35.